So, hello everyone, welcome to this session. So, in this session, we are going to see a toolbox called QSS Toolbox or Quasi-Static Toolbox, which we can use as an extension of MATLAB. So, first, let me tell you about QSS Toolbox and how we can use that. We will see. So, this QSS Toolbox or Quasi-Static Toolbox was first developed by Swiss Federal Institute of Technology, Zurich, in the year of 2005, and later on it was modified by Chalmers University of Technology, Sweden. It makes to design a powertrain system very quickly and in flexible manner and to calculate fuel consumption very easily. It can be integrated with other programs which allows for smooth integration with the functionality of MATLAB. So as I told previously, it is an extension of MATLAB and we can also use it with other programs as well. The most efficient use of this QSS toolbox can be made once the user fully understand the techniques required to integrate the toolbox with other programs. This allows a smooth integration with the functionality of MATLAB. So it has some advantage, like it use very extremely short CPU time. So on a regular PC, speed factor of 100 to 1000 for a conventional powertrain system. Obviously, QC quasi-static, this approach is not suitable for capturing any dynamic phenomena, those adequately described by differential equations, particular those type of problems we can't deal with QSS toolbox. The key idea behind this QSS toolbox is to reverse the usual cause and effect relationship of the dynamic system rather than calculating speeds from given forces. Based upon given speeds, the toolbox calculate the accelerations and determine the necessary forces. So first we will see how we can add these QSS toolbox with our MATLAB. So to download QSS toolbox, first we need to open our browser. Here we can type QSS toolbox download. QSS toolbox download. So once I type this and click enter, you can see there are several websites has opened, like MathWorks website. So basically the first version of QSS toolbox is available in their official website, that is Swiss Federal Institute of Technology Zurich's website. And this QSS toolbox, what you can see, it was developed by some MATLAB users. So it's available also in MATLAB community. So we will download this from the official website. So we will go in this website, IDSC ETHZ, this website. We will go here. So as it is taking, okay. So we have opened this. Now we will go in the below, and here we will see QSS toolbox option will be there. So what we need to do, we need to click this plus sign, and this link, this toolbox zip file, we need to download. So once I click this, it will be started download. So I have already downloaded it. So I am just pausing this. So once it is downloaded, you will see that this QSS toolbox will be downloaded in term of a zip file. If I go here, you can see this zip file will be downloaded. You need to just unzip it. So let me show that thing as well. So we will just right click on it and we will extract that into a folder. So once I unzipped it, it has already created a folder. You can see QSS toolbox, all the necessary folders and files are inside this. Now what we need to do, we need to go in our MATLAB. Here in the set path option, we need to click. So you will see there are several options. We need to select the second option, that is add with subfolder options. Once you click it, it will show for browsing option. So we need to select the directory where we have kept our QSS toolbox file, unzipped file. So I have kept here. So I will go here and I will select this QSS TP. I will select. Once I select, I will click this select folder option. You can see here all the necessary paths has been added with this MATLAB part. So what we need to do, we need to click save, and once it saves, we need to click close. Now, if we just run this command QSS underscore TB underscore library in command window, we will see one pop-up will came, that is the QSS toolbox thing. We can zoom it by clicking space bar, so it will be zoomed. So here you can see there are total 7 colorful boxes as there. So inside each boxes there are necessary blocks available that we need to use when we will model our powertrain. Now we will see how we can modeling one battery electric vehicle or pure EV using this QSS toolbox in very short time and with minimum blocks. We will see. So to create a blank window, we will click inside this Simulink and we will click this create model option. So you can see a blank model has been created. Now we will go here. So we will copy our required blocks. We will go inside the drive cycle first. From the drive cycle, we will just copy this and we will paste it in our window where we are modeling actually. If you want to read about this block, we can double click on it and you can see there are lots of documentations are there. Like this block loads the cycle data such as time, speed, acceleration, and gear number from the specified data file and makes it available on the output of the cycle block. Here inside this option, you can see there are various drive cycles data are available. We can select as per our requirement. So for now, I'm just selecting this NEDC drive cycle, this Europe NEDC option. I will click OK. Okay. Now you can see here the step size option is available. So the step size option we can select, we can keep the by default value as 1 second. With the step of 1 second, we want to fetch the data from the drive cycle. And we can check this box. So automatically it will select the time for the simulation based on the drive cycle range. So the drive cycle is for 1220 seconds. So by default, it has taken the time. You can check this block. Okay. Now we will go to our toolbox again and we'll go back. Then from this vehicle block, we need another block. This vehicle block we need, we will simply similar way, we will Control C to copy and here we will paste that. We can also read about this block here, like input ports are V and dV, where V is speed and dV is acceleration. And you can read W fill is the speed of the wheel, then acceleration of the wheel, and the torque of the wheel in Newton meter. So you can see the port names. So we will connect this V port with V port and this dV with dV. Okay. Actually, we are not going to use this I port. Actually, this I port refers to the gear number. We are not using this. So what we will do, we will just terminate the block, terminate this port using terminator block. We will connect this here. We are going to use this X total. So this is the total range or the total distance which is kept in this drive cycle. So I will use this after some time. For now, I'm just keeping it unconnected. Okay. Now need to set the parameters for the vehicle. Here you can see there are several options are there. So here for this example, we are considering vehicle mass as 300 kg. Rotating mass we can keep it as 5%, the by default value. The vehicle cross section we will set to 1.5 meter square. Field diameter we will change to 0.3 meter. Drag coefficient we will set to 0.5. Okay. Drag coefficient we are going to set 0.5. Then this rolling resistance coefficient or rolling friction coefficient we are going to set as 0.015. We will click apply and we will click OK. Now we need a transmission system to connect it with our vehicle. So we will go here, and inside this gear system box, we will double click and we will take the simple transmission block from here. We will copy this and we will paste it here. Now we will connect the ports. As you can see, those in two blocks, those ports name is same, so we will connect them. If we double click on the simple transmission, we can see there are documentation about the port names, what those ports are signifying. You can read that. So for our example, we are going to set gear ratio as 2. Efficiency we will keep as 98%, and idling loss we will keep as 50 watt, the default value. So these idling losses is creating due to friction inside the transmission system. We'll keep it as the by default value. Now we have connected vehicle, then transmission system. Okay, let me just show the block names here. So you can select this option to show the block name. We need a motor that will generate the mechanical power to drive our vehicle. So for motor, we will go inside this energy converter box, and from here we will copy this electric motor. You can see there are several blocks are present. So we will see another example where we are going to design one hybrid electric vehicle, and there we are going to use these engine blocks as well. So once I copy this, I'll go here and I will paste our block in our model. So also for this block as well, the ports name are same, so we'll connect it accordingly. So this is the acceleration of the transmission, and this is the acceleration of the gear. So we'll connect this. And if we just go here, you can see there are several options. So we can keep these values as what is already set. The default value we can set. We'll click apply and then OK. So we have connected the motor as well. Now we need to connect the battery from where this motor is going to drag the energy that is required. That battery block we can find inside this energy buffer box. You can see there are two options are available. One is supercapacitor and another one is battery. We'll need this battery block, so we'll copy this and we'll go here inside the modeling block and we will paste it here. If we just double click here, you can read the documentation about it. So the battery has an open circuit voltage of 130 volt when it is fully charged. We can only set the capacity of it. So we can keep this capacity as 100 ampere hour, the default value. We can change the initial charge of this. Let's see, we are setting it to 50% of its initial charge. If we just double click on it, we can read the port names. So X total is the total distance. So here we need this X total from this drive cycle. We'll connect it here. Then PBT is the power. So power motor will drag the power from the battery. So I will connect these two ports. Then QBT is the current charge of the battery. So it is not showing any SOC. We will convert this charge in our SOC. And this VBT is nothing but the energy consumption. Okay, we will change that. So we want to also see the voltage value. So what we will do, we will click this arrow to go inside this subsystem. You can see there are mathematical blocks are present. So here you can see battery voltage is showing, and this UBT signal is the battery voltage. What we will do, we will just copy this, and here you can see it is showing disable this link. So I will click disable this link, and again I will copy. So previously it was not giving me permission to copy this. Now I can copy this and change this. So let me change this as it is our voltage. So let me change voltage, and I will connect this output here to check our output voltage. And this is the energy. So I will just change it to Okay, I can keep that keep that name. Okay, so we have set it this. Now what we need to do, we'll go back. You can see voltage port has been created. Now, okay, let me see once. Okay, QBT is the charge and this is the energy consumption rate in kilowatt hour per 100 kilometers. Okay, now to we'll connect this after some time. So let start from this side. So the drive cycle range or the distance, it is in meter. Unit is in meter. If you just see, you can see the total distance is in meter. We need to convert it into kilometer. So what we will do, we will take one gain block and we will connect this input part from this, and inside the gain we will just divide this with 1000 to convert it in kilometer. Okay, now let me just increase the size. Okay, now we will use one display to display our distance. We have connected. Let me just change the name to distance. Okay, let me also show this name, electric motor, and this is the battery. Okay, it was previously showing. Okay, now we will also take one. Okay, we can also take search from here to fetch the display, or we can copy this as well. Voltage. Similarly, we'll see the charge. We'll connect another gain block to convert the charge into SOC. Charge. This is our voltage. Voltage. And this is our energy consumption. This middle one. Energy consumption. So we can write this name as energy consumption. Once I set the name, what I will do now, to convert the charge into SOC, we will take a gain block, and here we will just change the value, like to convert it in terms of percentage, we will divide this value with the ampere hour capacity of the battery into 3600. Now this is the charge. Sorry, this is the SOC or state of charge. SOC. So here we can see the consumption rate. Now, if we want to see the motor power that is required, we can take another display and we can connect it here. Now we will also fetch one scope to observe the pattern or the characteristics, and what we will do, we will just take this, like one from this SOC, another from this consumption, and another one is from voltage. We'll also set the name, like this signal is signifying voltage. We'll write this. This is the consumption rate, and this one is SOC. So it is showing the consumption rate. If we want to see what is the consumed energy amount, so what we have to do, we need one integrator block to integrate the value and show me the total energy consumption. I can connect it here, and from this I can take one block. Okay, let me just change the name to consumption rate. This is the consumption in the unit of watt. Similarly, this is the voltage is in the unit of voltage, volt. Okay, fine. Okay, this one is the motor power. Let me also change the name. Motor power. We'll set it to watt. Now, once I connected the required blocks with this, now, okay, let me just fix this. Now, what we will do, we will run this model. So we can click this. You can see once I run, it has consumed total amount of, okay, yeah. So it has consumed total amount of 4,790 watt. The consumption rate is 6.169 kilowatt hour per 100 kilometer. This is the consumption rate for this vehicle, and voltage reaches to 106 volt. If we just observe the pattern, what we can do, we can go here, and here inside this view option, we can select the layout to observe the 3 different signals in 3 different scope or 3 different section, and just set this value. And we can also turn the legend to understand which signal it is showing. Okay. Now you can see, okay, let me also see the distance. So distance is almost 8.282 kilometer, right? We have converted from meter to kilometer. It is a kilometer. To run this vehicle for 808.28 kilometer or almost 8.3 kilometer, the energy, the SOC of the SOC of the battery degraded from 50% to 46%, almost 4%, right? Here also you can see the voltage pattern. So previously during starting of the vehicle, the voltage was almost 123 volt. Now, after covering the distance, the voltage reaches to almost 106 volt. You can observe the voltage exact value here. So it is 106.5 volt, the energy consumption rate. Okay, and this is the charge, right? So here you can see we have only used 1, 2, 3, and 4 and 5. By using only 5 blocks, we are able to design a whole battery electric vehicle within very small time. Okay. So this is the beauty of QSS Toolbox. Now we have observed this pattern from here. Also, if we want to observe the motor behavior, motor power dragging behavior, what we can do, we can just select this option called log selected signal option. You can see, we will see how it works, and you can select here, and if I just go inside this, okay, so you can see this is the total traction force that is required. So it is sum of rolling resistance force, aerodynamic force, and inertia or acceleration force, what you call. You can just log the signal also here. Now, if we just go here, okay, also we can log this for the current as well. So this is the current IBT, this is the current. So we can also log this like here. Now I need to run this model again. So if I just run this again, you can see it has run. Now here inside this data inspector option, if I just click it, you will see all these signals which I have logged, it's came here. So this is the total resistance. We can see. Then this is the battery voltage. So don't be confused with this battery voltage. Actually, I have logged this here, right? So based on the block name, as it is already written battery voltage, so it is showing battery voltage 2. So it is the current actually. This battery voltage 2. This is the current. And this one is the motor power. Okay. You can see this is the colors. Okay, okay, so if I just zoom it, you can see the pattern is same. Okay, when it is going for a higher speed, the motor is demanding more energy from the battery, and the voltage of the thing is reducing. Voltage of the battery is slowly reducing. Also, the total resistance force or the traction force that is required to move the vehicle, the pattern is also same. When traction force is required, motor is dragging power and it is producing power. So we can also observe the signal patterns from here as well. Let me just uncheck this. Okay. So you have seen this is uh, very less time consuming. So if we want to design a battery electric vehicle very quickly, we can use this quasi-static toolbox and we can fetch the blocks from there and we can model our vehicle. Also, you have noticed that the run time is very less. It is taking almost 2-3 seconds, like it is 1-2 seconds only it is running. So like this we can model our battery electric vehicle. So thank you. If you guys came across about any type of doubts, you can reach out to me. Thank you.